Hi, I'm Gwanghyun at SNU, another of BeyondScene, higher resolution human-centric scene generation with pretrained diffusion. Our BeyondScene can generate exquisite higher resolution human-centric images with enhanced text correspondence and naturalness, complex multiple human scene composition, and higher resolution and scalability. Recently, text-to-image diffusion models have been able to generate controllable human scenes. However, scaling these to larger and more complex scenes with multiple humans remains a significant challenge due to limited training image size, limited text encoder tokens, and inherent limitation of T2I diffusion models. Existing attempts to address the training image size, such as joint process and dilation-based methods, often introduce new challenges specific to human-centric scenes, including unrealistic scenes and objects, anatomical distortions, and limited text-image correspondence. Here, we propose BeyondScene, a novel framework that overcomes these limitations, generating high-resolution human-centric scenes with exceptional text-image correspondence, naturalness, and complex scene composition. Our BeyondScene can produce super high-resolution images beyond 8K, surpassing the training resolution of SDXL by 64 times. BeyondScene employs a staged and hierarchical approach consisting of detail-based image generation and instance-aware hierarchical enlargements. Let's take a deeper look into detail-based image generation. Firstly, individual instances are generated in the training resolution of post-guided T2I diffusion models. Next, the generated instances are segmented, cropped, and resized to the desired size. Next, a diffusion-based impeding method is employed to create an instance-aware background, and to address potential inconsistencies in brightness and color tones, tone normalization is performed. To enlarge base image, we can use upsampling the image and perform joint diffusion process. However, this knife stretch induces blurriness and unnatural duplication of objects and humans. High frequency injected for diffusion can improve output detail while preserving content. Specifically, we first upsample the low resolution image and calculate Caddy map. Gaussian blur is applied to the map, and we normalize it to get probability map. The random number is sampled from uniform distribution at each pixel. If the number is larger than the value of probability map at each pixel, then there is no change. On the other hand, if the number is smaller, the pixel value within a certain distance is replaced so that we could apply pixel perturbation adaptively to avoid flickering effects near borders. This adaptive pixel perturbation is proceeded over all pixels. Then we can have high-frequency injected image. Next, we perform latent encoding and forward diffusion process. To resolve duplication of objects and humans in the knife joint diffusion, we introduce adaptive conditioning and adaptive stride. For each view, we check which human instances are present. If an instance is included, we add its pose and detailed description to the global prompt used for that view in the diffusion models. Also, to improve efficiency, we employ an adaptive stride for the joint process. We reduce the stride in regions containing humans, ensuring that these areas capture fine details. In contrast, the stride is increased in the background regions, allowing for more efficient computation in these areas. As shown in the results, baseline introduced artifacts of duplication, anatomical distortions, facial features, making the scene unnatural. Also, they struggle to generate complex scenes corresponding to the detailed descriptions. Conversely, our method generates images with minimal artifacts, demonstrating superior text-image correspondence, global and human naturalness, particularly in human-centric scenes. In quantitative comparison, BeyondScene shows superior text-image correspondence and naturalness compared to the baselines. Also, our method shows robust performance even with increasing human instances. Furthermore, ours was more preferred in the user study. Thank you for listening, and please visit our project page for more research and code.